Find the gauge pressure at point 4 in pounds per inch squared. In this problem, a manometer is filled with 3 liquids, A, B, and C. The specific gravity of each of these 3 liquids is provided in the data table. Point 1 is located on the open surface of liquid A, and the absolute pressure at point 1 equals 14.7 pounds per inch squared. To solve this problem, we'll use the equation delta P equals rho g delta H, which means the pressure difference between two different locations in a fluid equals the density of the fluid, rho, times the gravitational acceleration, g, times the change in height within the fluid, delta H. For this equation, keep in mind that the lower the height in the fluid medium, the larger the pressure. For this reason, some authors add a minus sign to the equation. For example, if we want to know the pressure difference between point 1 and a second location, point 2, then the pressure difference, delta P 1, 2, equals negative rho A times G times the change in elevation between points 2 and 1. If we want to know the pressure at point 3, which is located in liquid B, then we would have to evaluate the pressure difference from point A to the interface between fluids A and B, and combine that to the pressure difference from the fluid interface AB to point 3. In this problem, we're asked to find the gauge pressure at point 4. Gauge pressure equals the absolute pressure minus the atmospheric pressure. The atmospheric pressure equals 14.7 pounds per inch squared, and the absolute pressure at point 4 equals the absolute pressure at point 1 plus the pressure difference between points 4 and 1. And since we know the absolute pressure at point 1 is 14.7 pounds per inch squared, then our equation for gauge pressure at point 4 simplifies to the change in pressure between points 4 and 1. Therefore, for notational convenience, we'll reposition points 2 and 3 at the fluid boundaries AB and BC, respectively. Next, we'll write out our equation for the change in pressure between points 4 and 1. The problem statement provides the change in height between consecutive points as negative 21 inches, 10 inches, and negative 15 inches. The gravitational acceleration term, g, equals 32.2 feet per second squared. And the density of the fluid equals the density of water times the specific gravity of the fluid, where the density of water equals 62.4 pounds per cubic foot, and the specific gravity of each fluid is identified in the table. After writing out this equation, the change in pressure between points 4 and 1 equals 65,703 pounds-inches per feet squared per second squared. After converting pounds mass to pounds force, and after converting feet to inches, the pressure difference between points 4 and 1 equals 1.18 pounds force per inch squared. This means the gauge pressure at point 4 equals 1.18 pounds force per inch squared. When reviewing the possible solutions, the answer is B.